calculator one. They give us a function, and they want us to know the critical numbers of the function. So how do we find critical numbers? Okay, figure out where the first derivative is 0 or undefined. So you do have to take the derivative. Now you've got two options here. You could do product rule, which is what I'm going to do because I think it's easier. And you do have to know product rule, but in theory, if you want to cube this, it means take 2x plus 4 times 2x plus 4 times 2x plus 4 times an x minus 6. If you want to spend several minutes doing the algebra of distributing all that stuff, your derivative would be a little easier because you would just have to do power rule a couple times. But I'm going to do product rule here. So product rule says take the derivative of the first part. So bring the power down, lower the power by 1. It's got a chain rule component times 2 times the second part left alone plus, and then the derivative of the second part times the first part left alone. Now, I want to talk about the scoring as we go along here because even though that's a messy derivative, being able to do that was already 2 of the 9 points. So without, you don't even have to simplify. That is the correct derivative, so that would get you the first 2 points. Okay, we can simplify just a little bit here. We could say 3 times 2 is 6. I've got an x minus 6, and I've got 2x plus 4s. That plus 2 is the points. That's confusing me. And then plus, I've got 3 2x plus 4s. Okay, so you guys just said this a second ago, but critical numbers, to find those is when the first derivative is 0 or undefined. Is this thing ever going to be undefined? Okay, how do we know that so fast? Right, you don't have, well, it's okay to have fractions, but you can't have x's in your denominators. So there's nowhere this is undefined, so all we need to do is figure out where it equals 0. And even if that seems easy to you, and you feel like you shouldn't need to write this step down, you need to write that step down because they give you 1 point for showing that you set the derivative equal to 0. Okay, here's the algebra step that I think is a little bit harder. It shouldn't be harder, but I realize that it is. We need to solve this. So you might be tempted to subtract this over, and you can try that, but then you're probably going to be, this is a cube, and then you're probably going to be stuck. And the next step is honestly maybe the easiest algebra thing you've ever learned. But if you can't see to use it, then it doesn't help that you can do it. So, what do you think we should do algebraically? Yep, right.
Pull off the 2x plus 4 squared.
Right. This and this have a GCF. Together, that is a 2x plus 4 squared. That is the greatest common factor. It's easy for you to factor out a greatest common factor, but if you don't see that they have a greatest common factor and you don't think to pull it out, then it doesn't really do much. So this times this needs to give me all of this, so it's missing a 6x minus 6. I'm just going to distribute it. And then this distributed to this is supposed to give me that, so it's missing a single 2x plus 4. Okay, over here you can combine like terms, and now that it's something times something equals 0, if I can make this equal 0, that's a critical number, and or if I can make this equal 0, set that equal to 0 and solve. And they gave 2 more points here, so 1 for each. So that looks like it was pretty tough algebraically, but honestly, if you caught that GCF, then it wasn't too bad. Okay, any parts about A that you want me to review before we keep going? Okay, part B. For what values is G increasing? So again, it's probably going to take me a couple minutes to answer this, but if I'm interested in when G is increasing, should I be thinking about the function, first derivative, or second derivative? Okay, and this part A helps out a little bit. Critical numbers, they're not just things we randomly ask you to find. The reason why they're so important is these are the two places it might be changing direction. So you probably want to do a sign chart. Make sure you're adding enough information to this sign chart. Scott.
Hello. Calculators.
Oh, you brought them? Thank
That's
you.
me. At least I hope they're calculators. We'll see though.
They feel kind of empty.
Well, you know,
Did you
better make
empty them
$100
before you brought them
Maybe
here?
you sell those at a pawn shop for quite a few things.
That sounds like that's your plan. You brought them to me empty.
Well, maybe so. Double check. Have a good day.
You too. Okay, so we got two critical numbers, the two places it might be changing direction, but to know what's going on here, we need to test around these. Like, I don't know, 0 would be a good one because that's pretty easy. 5, -3. And I know some of the shortcuts you guys take, and you're developing bad habits here. Don't just show me the x values, -3, 0, and 5. Tell me that they're getting placed in the first derivative. That will help you out sometimes. Sometimes it's not needed, and sometimes it is important. So I've got the derivative over here. So if I plugged in 0, I would get a positive times a negative, which would be negative. When the first derivative is negative, it's decreasing. If I plug in 5, I get a positive times a positive, which would be positive. When the first derivative is positive, it's increasing. And plugging in -3, this has to be positive because anything squared is positive. And a -3 makes this negative. A positive times a negative will be negative. So here's my sign chart with a lot of information. It shows the numbers I plugged in, it shows what I plugged them into, it shows why I think things are increasing and decreasing, but all of that to answer when is it increasing. So what is the answer to part B?
4 to 3.
Good. This is not just good for justification, it gives a quick little visual of what's going on. It's only increasing from 4 to infinity. Okay, they also said justify my answer. So how do I know it's increasing from 4 to infinity?
The chart that you drew, the line.
Okay, that's true, but let's try to just hone in. How did I know this one answer was increasing?
Because it changed direction. Or no.
Is that a positive slope?
Okay, so let's refer to the first derivative. The first derivative was,
5 or greater than 0.
yep. That's plenty justification.
So,
I think it's increasing during that time because the first derivative is positive during that time. Yeah.
So just drawing a line chart where you already have the first derivative of 5 is greater than 0 is not enough justification. You have to also write it.
Sometimes it can be, but in this case, no, because this you're telling me that you think it's increasing because at 5 it's greater than 0. But what about 4.5?
Okay.
Why is 4.5 part of your answer but not part of your justification? That becomes the problem. Okay, and then last one, identify the x coordinates of the critical points which have a relative min. Justify your answer. So this line chart is paying off again because we can just glance at it and see that there is a relative min. Point, this was point. Where's the relative min going to be? X equals 4. We can see it right here. And why is that a relative min?
Because the first derivative goes from negative to positive.
Perfect. 1 point for the correct answer, 1 point for the justification. You can justify it in much, much, much less efficient ways. You just need to be careful. Sometimes when you guys try to write a sentence explaining it, your sentence better be comprehensive. You can't create holes in your logic. Similar to this one up here. This is not a good enough reasoning for part B because it doesn't explain why my answer was 4 to infinity and not 5 to infinity. Like, you would have to go further there. So.
Will they take points off if you go from writing G to F? Because this question is over G of X.
That's a good question.
I do that.
The answer is, I don't think they would count off on that because they don't try to punish you. They're not trying to be like extra unfair. But they're never going to put that in writing, so I would always try to use the correct notation. She was pointing out that in this function it was G, not F, so I really should have been using G prime, G prime, G prime. G prime is positive, G prime is negative, G prime is positive, not F. There was no F in this question, so. Not important enough to go back and change everything, but you should aim to be correct. Okay, anything to finish up that number 1? So, critical numbers, you need to know how to find them. Occasionally you need to see a GCF. That was the hardest algebra part there. Knowing where something's increasing, decreasing. This line chart gives you a quick visual. You've been practicing making that for a while now, and you're going to continue to make it in the next unit. Our next unit's very short because it's a lot of the same stuff, but that's important. And relative mins or relative maxes also got the information pretty quick from the sign chart. So if you can make the sign chart, you can get parts B and C. Okay, anything else about this first one before I put it away?